Here we are solving a question on waves that had appeared in 21st January shift 1 of JEE Mains 2026. So we have two rods A and B of different linear mass densities. They are joined at E. They are joined at E and their other free ends are joined to the rigid support at C and D. At ends C and D, two waves are generated, and these wave pulse they reach the end E at time t1 and t2, and they are asking us to find the ratio of the times t1 and t2. They have given us that the combined tension in the rod is 500 Newton, and they have given the respective linear mass densities and lengths of the rod. So let's solve the question. So in order to reach the joint E, each wave pulse is traveling the length of one of the rods, correct now? For example, the wave pulse generated at C is traveling the length of rod A, and the wave pulse generated at D is traveling the length of rod B. So I can say that the time taken will be equal to the length of rod divided by the speed, because time is equal to distance divided by speed, right? So the length of the rod L as it is, but we know that speed of waves on a stretched string is root T by mu. So therefore this will become L root mu divided by root T. This is the time. If I consider T1, the first wave pulse is traveling the length LA in a rod A, so root mu A divided by root T. Similarly, T2 will be LB root mu B divided by root T, right? So if I take the ratios T1 divided by T2, we see that the tension terms are same, because the two rods are in series and same tension of 500 Newton is generated on them. So the tension doesn't at all matter. T1 by T2 will be LA divided by LB into root of mu A divided by root mu B. LA is 2.5, LB is 1.5, mu A is 2 into 10 power minus 4 divided by LB is 4 into 10 power minus 4. This comes out to be around 2.5 divided by 1.5 into 1.414. On calculating, this ratio is approximately 1.178. So the closest answer would be option 3.